Let's talk a little bit about the strength of the acids and bases. The stronger the acid, the weaker the conjugate bases, and vice versa. Hydronium ion H3O plus is the strongest acid that it can exist in aqueous solution, and hydroxide is the strongest base. Any acid or base stronger than that will simply react stoichiometrically with water to produce H plus and OH minus. The conjugate base of a strong acid like chloride has negligible acid-base properties, and we consider it to be neutral. Similarly, the conjugate acid of a strong base like sodium ion for sodium hydroxide would have negligible acid-base properties. So if we look at sort of a schematic, we see strong acids like HCl, H2SO4, HNO3, and their conjugate base is chloride, hydrogen sulfate, nitrate. They're not bases. Hydrogen sulfate is amphoteric, and we got H plus conjugate base water. But then we got HSO4 is a relatively strong weak acid, so it's definitely not a base, and SO4, and you keep going, and you get down to some relatively strong bases. Ultimately, you see that the anions of some of your weak acids can themselves be weak bases. Like HF is a weak acid, but F minus is a weak base. Acetic acid is a weak acid, but acetate ion is a weak base. All the way down to hydroxide being our strongest base in aqueous solution, where water is now the conjugate acid, showing that water is in fact amphoteric. And you can see things like sulfide, peroxide, hydride will all react with water to produce hydrogen, sulfide ion, hydroxide, and hydrogen respectively, where none of those are acids. And so you can see that it works out. So let's look at a review of strong electrolytes. We must distinguish weak acids and bases from the strong electrolytes. Weak acids and bases will ionize or dissociate partially, generally much less than 100%. A strong electrolyte is going to be 100% or close to it. In this chapter, we look at the weak electrolytes, and they usually ionize less than 10%. Again, strong electrolytes will be almost 100%. So if we look at our friend nitric acid, it's reacting with water, 100% ionization to produce H3O plus or NO3 minus. Some people will omit the water and say H3O, HNO3, 100% dissociating to H plus and NO3 minus. So if we look at some of this, what does that complete ionization give you in terms of an acid? We want to calculate the concentrations of all the ions in 0.050 molar nitric acid, HNO3. So let's go to the paper. So we got okay, so let's say we got HNO3 going to H plus and O3 minus, and we said that the concentration was 0.050 molar. If this is 100% ionization, and so we'll look at initial change, and we'll call it after, since there's no equilibrium here and it's a one-directional reaction. If this ionizes completely, I'm going to use up all of my HNO3, and it's going to be 0 left. If I assume initially I did not have any of that when they came in contact with water, since the stoichiometry is 1-to-1, I'm going to have plus 0.050 molar H plus, which we're going to be interested in for the pH, but we'll also have nitrate ion floating around as well. This is an important skill if you want to be sure that you're getting the pH right for some of these solutions. So we'll look at another example, except it's going to be a base. And so we got our friend strontium hydroxide, and we know that it's 0.020 molar. And so let's get the concentrations of ions there. So again, let's look at the paper. And so we're down here. Now strontium hydroxide, when it ionizes into water, you're going to get some strontium ion, but you're going to get 2 hydroxide ions, and you've got to be careful of the stoichiometry. So if I do the same initial change and after, if it's still a strong electrolyte and this is still 100% ionized, this is going to go away, and then I'm going to have none left. I'm going to add that much of this because the stoichiometric coefficient is the same, but I'm going to have to do twice as much of this, 0, 4, 0, because the 2-to-1 proportion. Again, that'll be important to determine when you start calculating pH of these solutions, that you got to be careful. You'll be off by a factor of 2 on your concentrations.